Hello, what's going on? It's Junchan. Still in Madrid for my last day. I'm flying back to Berlin tomorrow, and it's about 40 degrees today, so super hot. But today we're doing some Purescript again, and let's just dive in. I've copied my log for today, and let's see where were we at? Where were we at? We wanted So there's two directions to go here. I could just go and try halogen because there's a lot of things that seems like maybe it's a bit sad. This whole commoditic approach seems really nice, and I would like to pursue it further. Um, but it is a bit of a glaring omission, the fact that we haven't looked at halogen as one of the key UI frameworks. So I could do that. Or I could double down on React Explore and think about how I can wire effects there and whether that would work or not. So just for the sake of actually having a little bit of staying power and continuing on what we've been doing for a while, let me try and look again at how we could solve that issue. What we saw last time, and I think there's a number of things that I've been playing with outside of the stream, so I'll just close those things. But here we go, browser chronofold. Yeah, one of the things that we looked at last time was this idea of this effect prime. Um, what was it? The effect prime wrapper. Effect and yeah, this UI.effect wrapper. And this was a commodity combinator to add an action that would be triggered in response to every user action. So a monadic action in the base monad. So some kind of output side effect is the way that I'm framing this. The question is, can we wire an input side effect? And so far, the only answer I have to that is that if we wanted to do this, one way would be to hook it directly inside the explore function, which we did once, and we did it, I suppose, right here. So if we subscribe here, then we have potentially something that could work. So is that something we want to investigate? Is there a way that we could actually hook a slot here, like inputs, and then that would be a monadic value, and then just run it here, including with potentially some startup info. That could be a way, right? In fact, why don't we try that? So this would just say input, and for now would ignore the output of input. And instead of just a component W, we would also take something, I suppose, in the base monad, which in our case is just what? It's just effects. So we just take some effect unit. The difficulty is how, so that's where, yeah, things get a little bit more interesting. I could do this, and then in theory, this is a little bit annoying. This is closing, and I suppose maybe if I close this and save, and then reopen it, maybe it won't be such an issue anymore. So now I need to change my uses of Explore, and Explore is used, I believe, right here, right? So here I would need to put my subscription, and right now this is where my subscription was. So render UI, and so I'm just trying to see UI here could be parameterized with the input, and then we could put the input here. So maybe we do that. And then we say, we say, well, input equals this monadic value. But in that case, we don't really even need to parameterize it here. And then we might want to do pure units as a output value. And that looks like in theory that just actually builds. So let's see whether actually it still does what we want it to do. Not with this, with this. And yeah, it looks like it is. So let's make sure we're running the right thing. Colon for prototype, exclamation mark. We are running the right thing. Okay, so that's pretty nice. So now the question is, okay, how do we make this be in the monadic language? That's the most difficult part because if we did, it would need to be somehow passed to send. You see that we have two UI here, which is not going to be let's call it page. Sorry, I'm sniffling. So how do we mimic this? Actually, let me think a second about that, because clock tick is okay, but I think we wanted to trigger, yes, an ink action. That's what we want, right? This way it's in the monadic DSL. So right now we don't even have access to that. So what would it look like? In theory, it would look like subscribe and then send, right? The problem is send is only accessible way deep in here. So how does it work then? Yeah, right here, send. I'm going to blow my nose. I'll be right back. Okay. Oh, let me check that my sound's working. It is. Okay, good. Right. So ideally, we want to send something like this, right? To have send, we need to be in the UI monad, because the UI monad gives us that handler that we need. So the problem is, oh, hold on. Yeah, no, the problem is that here we return a tuple that has these two things. And then we match when we do a build cofree actually takes that tuple. And I think it takes a tuple such that we give it an initial seed, or, well, no, give an initial seed s, and a function from, which is count 0, and a function from a seed, or actually a state, which could be a future state, to both a tuple of a, which is then going to be that's going to be my a, right? And fs, which is going to be counter interpreter of counter model. Then you return to me a cofree fa, which is, I suppose, a component counter space. So I suppose that's where you switch from a UI into a component, which is done by switching from, like, putting this UI into a comonad, which is the co-free comonad, right? So so the fact that this is UI, or it's a tuple of UI and something. Okay, I think maybe I'm thinking a little bit in a way that's not going to help. So let me first move this here because it's been a little bit annoying to move things around. And so yeah, I should look at what I want input to be like. Ideally, I want input to be something something a little bit like, given a time. Actually, I ignore the time and I send rep3 ink pure unit, right? So rep3 we can have, ink we have. So it's just really send that we don't have, right? So what if we said, well, input but with send? And then here we just pass input, which means that explore actually takes not an effect unit, but a handler A2 effect unit. And then we need to for A. And now input is really partially applied, right? So we need to get a send, but we're not going to get it from here. It's gotten from somewhere from the components, but it's not so easy to get it out. In fact, probably needs to be gotten somewhere. Oh, there is send here. Is that the? I'm not sure that's the correct send, but maybe I'm wrong. So input here being partially applied means that doesn't work. So it means that right now I'm thinking of somehow extracting send in order to pass it to input. But this is a one-off hook, or it's not a one-off hook exactly. Yeah, it is. It's just like a subscription. So the moment where I do the subscription, I need to have the callback. So I can't really do it afterwards. The callback being send. And another way to say this is that the state change that would be triggered by an external input kind of needs to be processed inside this render loop, which is using the React state as persistence, as its persistence layer to store the previous value of the of state and then persist the new value of state. So I suppose the question becomes, where would the data flow of like a subscription, where would it need to flow here? So maybe to understand that, I need to compare what a click flow looks like. UI send. Get the state, then extract the state with the send function. Extracting the state will give me that UI, and sending will I suppose getting to QW units. Oh yeah, it's UI of QW unit. So hold on. This is what is this? Right, there's UI of QW unit equals handler of QW unit to React element, and that equals QW unit to effect unit. I can put in parentheses, and which is what we're looking at now, to React element. So this send can we do this? Right, no, we can't because state is in a closure. Which makes sense. It depends on the current state. So we just need to hook in here this guy. And if this is a function that takes a QW unit and returns an effect unit, and send m is an effect unit, so I should be able to put it in an effect monad, do block, and then do input of what? Not here. Input of what? Input of send itself? I mean, I don't know. That sounds weirdly. Input takes a handler a. Oh, so maybe it's not a handler a to effect unit, maybe because a handler a is something to effect unit. So it's actually it is QW. Yeah, it is QW unit to effect unit, so we don't need to have a here. That work? Now function with co. Send, or is it send m? Basically, are we saying we're redirecting? No, I think I got this wrong. M is the co W unit. Which is inside UI, or return result of UI. I think there's something I'm not thinking of properly here. This UI thing, text send. And when I have the UI, I'm able to build a component out of it with build code free. And this UI will be passed at each extension of the comonad. So I need to trigger an extension of the comonad through some external effect. And here, it kind of means that when I build co-free, ideally, I'd have like some arbitrary hook in the React tree there, which is not great for decoupling. But if I had an arbitrary hook on my handler, that might mean if there's no such generic hook, I'm wondering whether it would just mean to have to implement it in JavaScript. That would be fine. Would be maybe not as satisfying. I have to wrestle all the synthetic event wrapping stuff. It comes from the Purescript DOM. That would be a bit hard. I'm trying to think conceptually, like this build co-free is wrapping this step counter. And when we do this send, what really happens in terms of data flow when we do this send? That's something that's not completely obvious. And give me a second, I'll be right back. I remember that's something that I try and do, like the data flow following of events in Purescript that's done. But here I haven't done that so well. So when this gets a JavaScript subscription in the browser, right? And there's a subscription that gets installed on this element of the DOM, and we click, and then this function send get its payload. But this function send, what does it have? And where is it interpreted, right? And I suppose it's, so let's move that, but I suppose it's here. But is there a complete mapping of that send function? I think not. I think this send function is not exactly this send function. Although it looks a lot like it. How would I know that? So where does this, so this send is this. So we modify the state according to runco. So I suppose this runco and the extension is supposed to do something with whatever we received in the M. So is this the M that we receive? If so, can we log it? And I suppose we probably can. So let's try and do that. Let's use the spy. We have debug trace spy, and we use it here, for instance. And we can use it exactly here. We can call this send on keyop and wait for the reload. And we have could not match type. Okay. Yes, okay. Yeah, we've changed a few things. So let's go back to input actually maybe not being written like so, but written like so. And then we should be good. And then it reloads, and then I have send on keyop. That gives me a thing. And so now I just want to see whether M that is being passed here is the M that we're expecting. So we'll just spy on M right here. And we'll need to import spy. And that doesn't work because instead of effect unit, we get unit because I did this do thing. And so maybe it's just not pure. Yeah. And then this is just a warning. Okay. So now if I hit, I get both. Yeah, look at this. This is the same M that's being passed to us. So what does this mean? It means that potentially, okay, I'm thinking maybe I'm starting to get this. Maybe. Okay, let's actually try by using this code here and say something like, we subscribe the event so that we receive the time, but then render, I think, is in a stateless, it's a pure function, I think. Then what do we do? Then this is this has an effect, right? So we could return the pure unit here if we wanted. And here I want to do something like actually r modify state blah. Can I do something like that? So I don't have the state, so that's a problem. But okay, hold on. The subscription needs to have access to the current state. So we need to get the state. And we could do this in the render monad. Let's look at this. So React class, and that has a render, and render is effect. Oh, hold on, it is effect. So why haven't I done that then for a while? Isn't this? And let's see whether we can just do the log thing. And then, what's that? Not sure, but let's do the log thing here. And then here, explore, get input, but I'm not using it. Okay, I think this needs to be indented properly. Okay, and log needs to be available. Okay, so that's actually compiles, but this doesn't compile anymore. Why not? Ah, hold on. Oh, input is a function from KW unit to effect unit in that case. Yeah, so I can't do this exactly. I need to, yeah, I need to fake that it takes an argument and just not use it. Yeah, that's it. Okay, so now now what? What am I expecting here? First of all, I have multiple subscription running, and so let's try and clean up. I mean, hold on. Is this really this subscription running right now, or what? It is. Okay. So I'm actually, this does work. I am actually able to hook. There is an effect monad in render, so I can hook into that render lifecycle. I think this will solve our problem. So because if we can do this, then once we get the state, oh, but yeah, okay, I see. The problem is that it's going to resubscribe every render now. That's the problem. So that's not what we want to do, but I think that's a common problem, is it? We don't want to resubscribe every render, of course, but so we don't really, do we want to then attach the event handler only on first render? But doing that somehow, does this give us the scope we want? We want to modify state. But in order to modify state, we want to get the state. So I suppose that's what we need to do in the subscription, and we do it only once, meaning here. And instead of this, we get state, and then we do also have send. Basically, we produce all that stuff. But but we fix the M. Is that what's going on? Okay, so now something's been registered, but it's not triggering anything special. And I think it's because we're not really extracting. There's something there going on about the M that we receive. Send M here. For this component. We extend the monad, we run co. That monadic value, W of A to R. Can I just pass the value I want here? Like, what do we want? We want this. So if I pass, instead of M, I say this, it's just effect unit, and we give you the M, call it action, and we make it like so, meaning its action is a co-W unit. And then we import stuff. We'll import inc from, okay, yes. So here, yeah, we do have a problem here because we'd want to pass these guys, but can I just copy it for now? Yeah, no, if I do that, it's going to be complicated. So I think I need to, can I try and thread it, pass it to explore? So instead of passing input here, I actually pass inc. How about that? And then explore does not take input here, which I'm not using anyway. It just takes inc. And inc is what? Inc is actually a co-W unit, actually. Look at that. So okay, co is function. So inc, okay, let's double check. co-counter interpreter unit. So it is codable unit. So explore. Explore has not been updated because probably it doesn't compile yet. And that's because send here is unhappy because it might be the other send. So let's say act. And act. So that's not the problem. What's the problem? I think I've messed that up. Let's. It was there was a do, but that doesn't solve things. And what have I done? Let's be Purescript React Explore in source React and explore. Wow, so slow. There's something going on with the internet. It says excellent. Just a problem with GitHub, maybe. And this is not a. I have not made a Git folder out of this, which is there we go. Explore. And unit render to space state. Let's move this. Okay, so in this case, this works. So what have I done? I suppose extract state act. It's strange, right? Right. Codable unit effect unit with effect unit. It looks like it's confusing this for this, but space state to pure. What a strange thing. Let's send. Yeah, let's remove the do. Maybe might be as simple as that. No, it's not. How about if I remove it here? Maybe I need a where clause. Let's see if it works. Where blah. No, because of the because I need this. I needed this. That? Oh, that seems to. Oh no, maybe not. Explore another value state. Aha. Okay. Yeah. No, that makes sense. I don't have state here. Do I need to indent this? No, right? So state. I need to have two let clauses. Action here, and then another one there. No. Okay, I have no clue what's going on here. could be because this W type is causing some trouble, because now the M, this means the same W. I think it always meant the same W, but maybe this code W unit here, that's not okay because this W gets specialized. Maybe. It's quite strange though. Trying to that's not here. It's here. Trying to match code W unit with effect unit with effect unit. Send modify state. And let's make sure that I'm not missing something obvious here. Okay, maybe I'm in the wrong do block. That's what's going on. I was in the wrong do block. Is that? Yeah. Okay. No. This is now it's in the do block, whereas it wasn't before. So that's one thing that changed. So then this compiles. It's just that, yeah, no, what's the problem with that? This compiles and then what? Then inc. Okay, so there's still some issue with the type here. What is it? Component W. Instead of code W unit, then W, is it counter interpreter versus co-free counter interpreter? Co counter interpreter units. Passing co counter interpreter unit. Co counter interpreter unit, but maybe it's a different W here. It is definitely a different W. Because it's this whole W that holds this whole thing. Okay, so W prime and W prime. Can we do that? And does this work? It does. Okay, and then can we just then say, no, that we can't. Okay, what happens here? Still works, sends key ups. Okay, but then if I do that, like my send is screwed. That's weird, and that's because maybe here is code W prime. Hey. And then here, what's going on there? And then we have a problem with something else. Apparently, in pure component, gets back this effect. I'm ignoring the return value. I'm ignoring the return value, but it has a type, and maybe that's creating a problem here. Right. Because actually, I need to get that and pass it in here, don't I? Oh, it's not so straightforward. Um, I receive a subscription. I could modify state, but then now my comonadic value has moved forward. And so, well, I need to put it back into the state, which I do, and then when it's picked up by this get state on render, then hopefully it's a new state. But it means that this pure here, maybe that's not needed anymore. Or it's more like void and then pure unit or something. Can I do that? Yeah, I think basically we're saying maybe this is another W, or is it really W prime? No, it's not W prime. Oh, state? Maybe I need to change the name of state here. Mm -hmm. Mm, I think I'm a bit stuck here. I'm not sure this is the right pattern. Let's look at something like Purescript, React Basic. And there should be examples, real world example app. And let's see whether actually there's some hooking up of things. The beginning, launch half, okay, roots, some auth and routing, and then passing routing manager and auth manager. So yeah, that's very hookish right there. And these look like input things like routing will be things potentially like browser navigation thingies. Let's just double check this. And okay, hold on. Where it is actually using React Basic hooks. Oh, it's not using Basic anymore. And conduit. Okay. And component routing. So it's defined as a component, which is interesting. This is pretty neat. Routing IO plus, and then routing IO has this bunch of things that look like actually a comonetic interpreter actually. And navigate is this input thing as well as redirect, I believe. We can how does this work? It's just this unique component that has effects. So when this is done, the routing IO thingy is off, or routing, and that just gets ran. And I suppose I need to see what run append does, right? I think that's something that's missing here. From config append. And it takes env and append, and env is auth and routing. So that is just run reader T. Right. So I think that's the three-layer cake with reader T also holding functions. And holy moly, this is using halogen. React.halo. Halogen subscription. It is using halogen. So apparently that doesn't, I don't think really fit, except was also using React Basic hooks. I didn't know you could do that. But does it mean that the okay, there's a notify and listener here. Does this mean that this whole bit is actually managed by Halogen? Let's try and find out. There's Halo there, and then run append. There's run reader T. And then monad routing. So being past that routing IO thing, the monad is going to be such that being past that value, we will do what? We will ask underscore routing navigate, which is the what? Which is this, I suppose, underscore routing, and then navigate will give us this function, router.navigate. Where does router come from here? Comes from router make router. So that's an external hook of sorts. So something that presumably that routers will make router then does a subscription for. And then we get some value, and we don't get a value, we get that function, and we pass it the route. Yeah, that's too much indirection for me to understand offhand. Plus, given that we're doing halogen here, it's really not clear how much halogen takes of the responsibility to do notifications and so on. Okay, hold on. And the router came from routing web.router. And Pursuit and web.router. That doesn't, that's not from here. Where is it from? Effective record. Okay, I was not looking at the right thing. It's in Purescript React Real World. Should be looking. Spago. Web router. There is a Purescript web router. It's just not in Pursuit right now. And that's for React. Support with asynchronous routing logic, built using React Basic Hook. And then out into Plex. That's pretty cool. So maybe hooks really is the answer here. It kind of makes sense because in theory, we could have hooks at the top level, but I just need to find a way to rewrite this for hooks. I need first to find a way to rewrite this for React Basic, which I remember trying out, and then try to rewrite it for hooks. It's still pretty complicated, right? But it seems like it would address the type of pattern that we're looking at. Let's look again at Purescript React Basic hooks and see how well this pattern of being called from outside is taken in. Yeah, there's no more testing here. There used to be some, and all of the documentation is in a weird state. Before 10 examples. And async. Async loader, blah. Yeah, that doesn't sound right. Control input. State. Input on change. This all hooks into Purescript. I think there was an example folder somewhere. This is a Purescript example from the, okay. I think yes, there was an example here, but I'm not sure whether it included something an effect on the outside. Still very much on click. And let's see, hooks. I'm looking at this because this is one of the most, this was one of the nicest things. And plus it follows where the React ecosystem is heading. Let's see if in the previous stack there were examples of tests. They weren't. 6, no. It's strange. I was pretty sure that, there we go. An example from version 5.2. And suspense, reduce to counter context. Maybe app would be the one that's interesting. Quick context. No, I think that's actually the React context. That's a way to pass things down into the component hierarchy. Use context, counter context. Yeah, this MK example. Have a store with counter context. So everybody shares the context that it did in that case. Maybe not that. Af. Example, our boundary capitals was af. The main use af demo, which is a key as a prop renders both the loading state and the final result. Component, use af, get key fetch, get key. And fetch is a type class. And so component key cat. Get the cat state from fetch cat key. And when there is a cat state, then it shows the cat. And fetch k for cats. Just delays and get something from the fake cat DB. That's the fake cat DB. And on change set the cat key. And this gets the cat state, which maps all the cats and thing, but that doesn't mean that there's some dynamic aspect to this, although could there be some kind of subscription here? Not sure. I mean, this is in the render, so no, actually. So let's see, React hooks and live data fetching. Subscription. How does this work in this case? Use subscription, loading error data, and watching data subscriptions. Yeah, that's with the hooks. So you use subscription. Hold on, let's This is dismantled. So this is not indented properly, or am I dreaming here? No, it's not indented properly. I think all this should be indented one back, right? No time data. If data get online user list. So presumably, yeah, this subscription hook is receiving live data. Web connected to live sources. So let's just say React hook subscription. Manually managing subscription in async we're using hooks. Use subscription. And so let's just do use subscription, type value, get current value, and subscribe. This function is passed an event handler to attach to the subscription to return an unsubscribed function and remove the handler. Yeah, that's more like it, right? So maybe I should look for Purescript React Basic hooks subscriptions. Maybe putting subscription like so. Basic half. So halogen subscription. Ah, yeah, that's effect unit. Okay, what's that? Without halogen. Yeah. Using the hash pass pair to break it down for you. Effect unit is describing a subscription. Yeah, I remember that. What is that from? What's this? Events and signals. Wire React router returns a signal the current values. Use signal hook from wire React. Interesting. .x, and then this effect. And that's from routing library and React Basic hooks. Yeah. Depends also from where it comes from. And router. Go free React router. Right. Remember that. That doesn't. Does this work with Purescript React Basic? I don't think so. It's also pretty old. Yeah, no, it's like low level React. It would be useful for me to see how that works. Main p create element browser router, and then router in the middle. Right. I mean, routers are not a bad example, but they're also quite complicated to understand. Okay, I'll take a little break because I'm getting pretty thirsty right now. Okay. Purescript halogen hooks. Yeah, no, we don't want that. Consistent halogen hooks. So no clear examples of React basic hooks and subscription, but I can see. Let's try. Yeah. So how about subscribe or even event? Is the effect raised for global restrictions and effect from the business? That sounds like exactly what we want. Events, global use effect. Effects only perform a single type of component instance. And every vendor. That's for registration. And right, so use effect that do timeout, set timeout, blah, block show. So that's exactly the type of stuff I'm interested in. And so I think hooks is, I think I'm back into thinking that hooks might be another alternate route here. So let's try and see where we are. We're choosing and evaluating UI, Purescript UI frameworks. And we want them to have, ideally they hook up to Common Edit UI, connect to React, and they can have what we could say are async effects. And yeah, Common Edit UI really means a go-free DSL kind of thing. So, and what we've been looking at was Purescript test DOM, where we couldn't hook external effects. Purescript React Explorer, where it's also unclear where to hook external effects that correspond to a particular component go-free DSL. So we're able to do like logging at the top level or like a simple counter, but we can't, a simple console show, but we can't really so far trigger an effectful thing at each render, because I think because we're basically stuck into this model where we're doing this kind of where the component itself, which is extracted from state, is advancing purely through through its state space, with only this persistence trick that I think basically I'm still a little bit shaky on how what exactly the data flow is here, to be honest. Sorry. think the fact that like this on key up there is the fact that this send function becomes the thing that gets called and then becomes therefore the thing that does the modify state. So let's write this down. This send function is called by React's JS JS callbacks. Therefore advances the state of the commodity component. It's still not completely clear, right? Like it's rendered with, I suppose, this send being passed to it. I think I need to expand what this really means in terms of the types. Extract, whoopsie, extract is WA to A, meaning, hold on, is that just WA to A? It is. Right, so state's just a way to send. Yeah, so WA to A, it means it's component W, I believe. Now we pass it state is, yeah, it's a component W. So we pass it component W and we return therefore a UI of code W unit. So that's what extract takes. But when we pass it state, actually, I'm not sure that this is right. I think render expects a React element. Am I right with that? Effect render a React element, yes. So this should be of type pure. I don't even know how to write this. By the way, it's getting so hot in here. Yeah, you know what? Effect of React element, okay? Yes. And so, fine, so extract. Maybe we should say state send. Okay. That's a type of React element. And so the place where we have React element here is UIA So when UI A gets past the handler A, so I think what we have here is UI A, so UI of co W unit here. And I think send is a handler of co W unit. And so when pass extract, or when actually state send, therefore is of type React element. So there's something missing there. I'm not sure this is right. Ah, no, yeah, extract. No, hold on, it's not right. It should be a W of React element, but so it's a W of React element if actually we get past if this associates in the other way. Meaning extract state will give me a W of, no, extract state will give me a UI co-unit. And therefore, extract send applied to send will give me the React element, right? Because that is in fact parenthesized like so. Such that this is in fact UI co unit applied to handler co unit, and that's exactly the React element. And so really what we have is in fact state being the W UI co unit, meaning state being really component W. And then we restore our sanity. And so when we extract the current UI co unit, but we pass it the a state function, which becomes that send, that we pass it a send function, which then is the thing that gets could it be different at each instantiation? It's possible, right? It's not the case now. We only pass it the same send m, but it is different because send m will take into account what the current state is based on actually applying m to the current state. But I think we need to also unpack this. I think I've done this before, by the way, but probably worth doing it again. So let's make sense of send here, specifically of run co, like this guy. So this, in theory, is actually of type, I mean, clearly it's of type component W because we pass it back to space. But it's probably indeed the next component W, right? Based on running M. So like what's the run code type? Run code is this. So run code is all that stuff. Let's get ourselves a bit of space. So it takes an M, which is this co WA, meaning yeah, that's the co-monadic, right? So it's the monadic action. Co W is an M, and of some whatever carrying some A inside it. And then we pass it some function that's in the comonad is basically able to say, well, if you pass me an A, then I know what the result is, and then I just return that result. But the result is not in W, which is a bit strange. I think if we use extend, then it becomes it is in W. Let's because R becomes this guy, and so really what we have with runco extend is a little bit more tricky. It's or runco m well, let's just say yeah, runco m extend. Can we? So we have yeah, we don't need these guys. Arguably, we don't need these guys, or even maybe even the superclasses. And so runco m extend is going to take a co WA, or okay, so let's actually say that we haven't partially applied it to m. It's going to be a bit weird, but and then we pass it extend of something. But extend takes two arguments and returns WB. So the R is a WB. So yeah, that's really the point here. So, so that's why we stay in component W. We could, if we had something that returned an R not in the W, then we couldn't use this here. But here we use extend with const, which so okay, I'm not gonna write this here. It's gonna say extend const. Where is extend const? Extend const is so WA to B const state. So const state. So it takes the state and it just returns the state. That's strange. No, it's not what it does. It takes const is what's the signature for const? A to B to A. So let's write this down. A to B to A. That's just const. So extends const is going to be, is association happening in the right way here? Is it first extend const? Such that that first function is WA to B a bit lost here. we can say that based on run co, whatever is here has this type of W A to R. And extend yes, yes, yes. Okay, so it's a command full of functions now. So that's where things are a little bit tricky. Because when we extend, our WA, I think becomes A, but I think our B becomes a B2A. So that's where things are a little bit tricky. And I think I'm also getting confused with the names here. So I'm going to say this, and then a WA to B, and it's a WA to Y to WA. Really? Oh my, that's tricky. I don't know if that's really what I'm looking at right now. Okay, let's maybe start with the other direction. What about state then? State is just a WA, right? It's really just a component W, right? So we know that A really is that co-W unit. We don't care so much about that, but then, so yeah, the question is, how does this associate? Let's try this. Yeah, so it does associate in this other direction. Okay, maybe not. Yeah, no, so it doesn't extend, it doesn't associate in that direction. So extend that does take const as its first thing. So its argument. And so it seems in that case that X will be WA and B will be Y to WA. Yeah, no, I think that there's no way around that. And then WA to W of Y to WA. And does that give us a W of A to R? A W of A to R, where R is WA? Yeah, it does. So yeah, that's it. So we give it a WA. So it's just a little bit hard to understand, but that's because I think I'm not using my previous knowledge of what extend does. But also, I think extend const must be a pattern that that maybe I want to know about. Command extend const. What about that? Can you give me something? Extend const command. No. I think let's look at Chris Spanner's slides on common ads. And GitHub, common ad example, is that? Yeah. And slides here. And okay, streams. I think there were some introductory slides that extend. Yeah, it can't be searched for. But maybe the source. By view, abstract common notation, extend, way to be the. So yeah, the idea is that if you give me a WA and a way to convert WAs to B, so if you give me a commonality value, which let's say is a space, and a way to take all that space to one value, then I can then rebuild something full of that new value. Like I can fill the space now with that new value. So if that extension there is const, but then we're in that, we have this difficulty of having something that is then sort of partially applied, that it's going to create a comonad of functions that await for a thing. What does it await for, by the way? What is that Y? The R, no, the A. Yeah, so the A, hold on. Yeah, the A to R. So this ends up being the actual A, actually, doesn't it? I mean, the A here. So it means we wait for the result of that monadic value M. That's the one that we're waiting on in order to then decide what we do. So the pattern is that then once I have that, I can finally rebuild my component. So I kind of open up my current component such that being past the monadic value, I know how to move it forward. But what I'm unclear about is where does the recipe to pass a monadic value to the comonad, is that just in the run code? That might be just in the run code. The run code now, so how to do this. Let's look at the run code. Run code just opens the comonad, which is of the type I know what to do with an A. That's the thing. It's like that's exactly the pairing, or the transformation of a comonad into a monad is exactly that. Is the monad is the thing, is the comonad full of this function waiting for a monadic value? That's the essence of co. I think that's the learning there of what co does. And so when we extend um, with const, we're kind of creating that shape. And take our comonad and we creating that shape that makes it waiting for a monadic value, and then we pass it that monadic value. Hold on, actually, um, run co. Yeah, we pass it that monadic value, and um, and if we can create that comonad full of things that, given that value a, will give us a result, then we're good. And in our case, the result we get is just a result. Um, it's just passing const, which I think has the result of giving us like allowing us to have to return that R, which is a W, which is a WB. But yeah, the R being actually the W8, like it's the next comonadic value. It's a bit tricky, huh? So const. Okay, so let's pop back the stack here. So we get some intuition of how extend const state works, which is that it knows how to pass the M and move the whole comonad to its new state. So we're still in a kind of like a who calls what problem here, because when we extract state send, we this is where we actually create this. I should have noted the learning from that part here. When we extract state send, we build a UI CoW unit so maybe I'll put this like here. We extract the current UI from the component and gives it the actual implementation of send it's waiting for, which knows how to apply the monadic action to the component again, to the component such that when we pass this UI, such that we get the new React element. so that we get the React element. Um, um, yeah, my hesitation here is, um, are we returning the next version or just the current version but with the next date? I'm a bit confused here about like the order of things. When we pass it send, we do a stateful action which modifies state. Yeah. So a modify state is going to trigger a re-render with the new state. Yeah. Um, so it knows how to apply the model extraction system, and by calling modify state will retrigger a render with the next state. So that's the event flow here, right? It's I click, I therefore execute this callback, which modifies state, and then boom, that actually re-renders with the new state. And this only gets executed once, but this modified state gets executed at each. Extract it. Is it correct? No, it's not exactly correct. Right, no, it just installs that send hook into the React element such that when it gets called, it will modify state and then therefore kind of do an event loop thingy. Okay, let me try and rewrite this here if I can. Event loop would be something like extract send, extract state send attaches a event hook which when called moves to the next state. Then modifying state calls render which attaches the next event hook. So actually what gets attached through send is each time different because each time it will take the current state. And so if we want to inject ourselves into this event loop, then what do we do? Okay, first we drink. What would we want to see then? We'd want to attach the same way that we're attaching here the send to state. We want to attach our event source to send, same thing, and then have our event source do the modify state thing. So, so. Ah, hold on. Ah, yeah, and then we will reattach. Yeah, so I think that works. We're just saying that it will be something effectful. And we'll attach our event source, our input, and we'll pass it send, which is something we've already thought of somehow, but it wasn't here. Um, and this will be input, and input will take one of those guys, and maybe that's where I was missing something. I think it'll return effect unit. There's kind of a registration thing going on, I think, because we pass input, it will then, so input will take a handler, send, and then, so therefore input send will be an effectful thing, which we can then just sort of execute without caring about the return here. And so then we can maybe imagine an input. It will be something a little bit like this, but maybe we'll just actually pass it and see whether we can muster. Um, ah, W prime, yeah, yeah. I think it's the same W, but we'll see. And so here now we have trouble with this, because here what we want to pass is maybe something like this. Um, so we want to pass something that basically hold on, so there, let's call this input. And then input is something that is not exactly of this type. It's a bit more complicated now. It's of this type. And so it really takes a send. And then it uses send. And it returns pure unit. And then we erase the type. And then what? And then. Ha! We did it. Whew. That's good. Oh, what's going on there? Oh, that's really strange. Ah, there must be, yeah, okay. We must be registering things too much, too many times. We want to register them only once, and I think instead we're re-registering everything somehow. Um, so I think, yeah, that's where we need to follow the more sophisticated pattern of like returning effect to effect unit somehow and running this only once, I think. But that's pretty good. That's pretty good. That's really good. Really happy with that. Um, so basically, it means that we need to do that thing where we only subscribe once, even if we just need to change the handler, basically, right? Because the handler, because the send function. So if it's been registered, we just unregister and reinstall a new hook, which has the new send function, I think. Is that right? Subscribe to an event by putting callback. Yeah, and returns a canceller function. So we need to cancel it every time, or is there something to the pattern to resubscribe the event, or where will we see this? I think maybe it is actually in the SDOM code. Maybe here, subscribe. So we subscribe to this event, E, and then we get some other new things. We do some changes, and then we get the unsubscribe thing, and we return that. Then when do we use unsubscribe? Like we do the same thing here, create an event, create a listener, add an event listener. That's kind of a low level handler there. Given a context and an event, is able to move to the next stage. We get all of these subscribers. We get updates and we subscribe them to updates. Where do we run unsubscribers. Oh, but that's for arrays, which are complicated. And it's only when we detach that we send, that we maybe run the unsubscribers. So what's the deal here? Get the unsubscriber. Yeah, I mean, if we re-register a different send each round, then I don't see which we have to do unless there's some smarter way to do this, which we can't see. Then we need to unsubscribe each time. So here we get the unsubscription, and we maybe would store that in state, and then we'll unsubscribe to the previous thing. It feels a little bit weird to have to unsubscribe and subscribe each time. Can't we mutate the subscription? I think there was actually a thing to do that, maybe in AF or so let's look at FRP event again. I think it's Purescript event. And look at the all right. Can make an event, set a callback to the subscription function. But we probably want to use create, yeah. Subscription event operating callback, turn to cancel the function. Isn't that case of like dynamic resubscription? Actually, hold on. Isn't that part of the code? Do I have my SDOM example somewhere? Lots of questions. Did I keep my as done example? If I did, where would it be? Let's see. Browser confold. Am I on the branch? Is there Git here? There's not even a Git. No, Git hasn't been initialized here. There's a Purescript that's done. Maybe it's in there. And maybe I use the test or the example to play with it. I did not. And there's some stuff in there, but actually there's async, which I think maybe is what I'm thinking of right now. Yeah. I think that was the case where I think things were reattached continuously. Pretty sure. I'm not 100% sure. Just feels weird. Okay, let's think about it differently. Let's say we can run this only once. Then maybe out of that, we get, okay, think about this. We want subscription to be run once. And then possibly we want to get something out of that that we can put in here that in fact changes the subscription. So it seems like that means inverting control again. Might be possible. I think these double control inversion things happen often with event management. So, okay, what would it be like? It would be, we register the event. Okay, let's think about this. Probably want to actually commit that stuff because it's a little bit uncomfortable not to have this in a Git repo. Yeah, Git ignore should have also .parcel cache and dist. And that sounds good. And right. And then I'm saying something like what? Well, okay, I have some init input function that would do this thing. To be honest, it could, I think if it was just this, it would work. But just do it like this, and so we execute once, but maybe it would return that function. How would that even work? Yeah, right. I think he would do something like, yeah, it just going to push something, and then it's going to return that push value. That doesn't really make sense. I'm trying to say, we'll subscribe the thing with some function. Where is that function being pulled from? It needs to be, well, do I want it to be something that can be mutated? No. I think it's that there is this inversion. It's just tricky to think about. I hope I'm going to get better at this. Um, Initially, you subscribe it with some function you pass. Some function you pass, but that's maybe you're waiting for something. Uh, um, there's this idea here, right? It's F. Like how is this working already? Something like we get a push from that event creation. The event itself, we pass it. So that we get all of the events then that are generated by this. And then for any events, then we'll just push the new model, and then the F that we got from extracts from the events. That's a pure function from the old model to the new model. So that's not what I'm looking at. That's not what I'm interested in. This is more like somewhat this like this modified state, this function from state to state. That runco is kind of executing. That's in the shape of that comonetic thing. So not that. But here we do get a push out of attaching that we can use to funnel things. That's the way that it would work. I think, okay, maybe I'll end with this as something where we could try it. So where are we? we did do that. We did it by what? By extending explore, which ties the knot with React modify state, adding an input handler which we pass the modify state send um, it's like that's the end of the world effect, right? Like the send implementation. The input handler gets passed. So it's not perfect, right? There's several problems with the fact that we can only attach it at the top. That's a problem. But maybe we can manage somehow inside. If this render thing actually includes a subcomponent, then we could also explore the subcomponent. I'm not so sure actually whether that's a pattern or not. So let's see the problems. Can we use explore? Can we pass a local input to a local explore in the component tree, deep in the component tree? Then we need the more urgent one is we need to only subscribe once with some mutable handler. Oh, maybe with a ref it would work actually. I wonder whether I've seen that somewhere. It's just popping up. So a ref for what? For the send function, for send. So that we subscribe once with the initial ref, the mutable reference, and then some other part of the code, basically the Explorer version of the code also mutates that ref. Yeah, I think that's viable. Or we unsubscribe and resubscribe each time. Yeah, actually, if this event was not interval but delay, or yeah, or timer, I think. Instead of set interval, it would be set timer. Then I think it would work. Let's try that. FRP events. We need the event timer, time interval with time, debounce, set. There is no such thing currently. So we just need to, well, we need some reference to the previous thing. So we pass it here. And we return it. It's an effect of a effect unit. Is that what we want? And we pass it, we thread it, and then in Explorer we get it here, or maybe we do the state things in here, get the unsubscribe from here, maybe we put it in there. Right, that's possible. We say we're not just interested in space and states in it. We're also interested in feels really dirty, but unsub, and the initial unsub is just pure unit. We don't care. It's really effect unit, and then we get we execute unsub, which would be a no up first time, and then we get unsub a next thing, and we are modify state maybe we should do this. We just pass. No, that's not going to work, right? No, extract state is then passed send. So we could just pass unsub next here. Call this effect unit. Call this u, and then pass unsub u. It's not very pretty, but that'll be better than this, and I think maybe it will work. Flash code 0, input send. Yes. Unsub next. Yes, and then it's not there. Right. Well, then I suppose, yeah, I suppose unsub. And, okay, actually, no, this doesn't work. Code W. So maybe like so. Yes. Except still not. Oh, that's strange. So maybe that top level monad is not good anymore. Pure blah. How come? Pure W with effect unit. Ah, right. Yes, of course. Yeah, that doesn't work. No, that's a mistake. Shouldn't do it like this. Maybe I just do this. Let's see, because now I need the send. So maybe I do put just unsub here. And then I just re-register the next unsub. Oh, hey, yo, how's it going, Ramsey? Good to see you. Is life good? Um, just to let you know, I'm kind of wrapping up. It's like about 40 degrees here, I think. Let me double check, making sure I'm not telling lies. 37, yeah, it's pretty close to 30. And yeah, it's hot. So I've been streaming already 2 hours and a half, and I was planning for an hour and a half. So I'm definitely at the end of my rope here. But I'm happy I succeeded in doing something I've been a little bit dreading, to be honest, because it's kind of hard. Um, and but sort of managed it. Um, and that is to do just the following thing that maybe will work here. Fiction level unsub. Yeah, we don't need that today. And okay. And same here. I'm just going to do this. All right, yes, that should work. And it's not a lot, but it makes me happy for now. Oh, okay. Just give me this, please. Is it working? It's not working. Why is it not working? Ah, yes, of course, because I need the magic that makes it start. I need to pass input to send. And there we go. We have a nicely incrementing counter using Purescript React Explorer, which is a fairly obscure library in the Purescript ecosystem. But yeah, as you see, it's getting a little bit wild here. That's because I'm resubscribing each time a new event handler. And so at the 10th round, I have all of the event handlers subscribed and they all fire at the same time. So definitely don't want that. And I need to work this out, but that's what I was doing here, trying to work on unsubscribing and resubscribing. I was also thinking that maybe there's a way that we can subscribe once, but then mutate the subscription, the handler, using a mutable ref. So that would be the other approach. So, and then the other thing I'm going to look at next time also is, yeah, see whether actually this is kind of composable in the component tree or not. And then I think I might want to look at Purescript React Explore Basic, basically, which doesn't exist yet, but can I rebase, in some sense, rebase onto Purescript React Basic, and maybe then Purescript React Basic Hook, because then maybe Purescript React Basic Hooks would offer a better way to do this. But I suppose this is delegating quite a bit to this explore function, which is kind of tying the knot as I understand it now. And using therefore React state modification as the mechanism of advancing the UI. I'm going to write this down. So with Purescript React Explorer, we depend on Explorer, which uses the React state to as the event. So as the event loop trigger, I think is the way to say it. Don't even know whether that's satisfying or not. And then and whether we want to use this as a base or not. So I suppose the other sort of design space that we could explore here is, can we move Purescript? Can we move the monadic approach, or make the monadic approach more decoupled from React? I think that would be quite a big move with a lot of progress, possibly, because then we could say, we're just instantiating React as the UI framework, and therefore we use React state as the event loop, and we use the DOM actions, the registration of outside events in the DOM through React. And maybe I should write this down. We would instantiate Purescript Explorer to React by, what would that look like? By choosing making Explore use React state. I think we need to decouple. We would need to decouple the render loop from state management, because right now that's both are in Explore, and that's leading to a little bit of confusion, right? Because like we have render and then all of the state management thing. So if we decouple that, then possibly, I'm not sure how that would work, because right now Explore does return this React class, so we need to return something else. And then I think maybe this would allow us to then go towards something that is maybe more ECS-like. Because then the rendering, I mean, it'd be hard to tease things out of React, right? Because it's a little bit hard to understand. Okay, maybe that's not exactly true. It's not so hard to understand, but the delegation to React is a bit ad hoc, meaning it's a bit opaque, actually. That's what it is. It's opaque because we have opaque and ad hoc. Okay, ad hoc because state triggers re-renders, and yeah, that's really what it is, because state triggers re-renders. And I'm not sure that we want to be in this paradigm. And the problem that if we don't use React, then is there a way that we can say that, oh, we use React, therefore we know that state triggers re-renders, therefore we we shape the UI like this, but then we're like, oh no, state doesn't trigger re-render now. We have a lower level framework where we do something else, and then we're in charge of manually triggering a re-render and then manipulating state elsewhere, which is a bit like what is it, Immer.js? Not sure that that's exactly what I was looking for. It's part of the three hook. Is it React 3 Fiber? That one. Actually, is it Fibers that do that? No, I'm not sure. Do's and don'ts. I think that's might be the one for performance. Well, that's the 3 one. Docs, Java hooks, API. There was a document in there at some point, markdown, pitfalls. Do not create objects in groups. Amount things. Often occurring React state. That's right. Dostant, that's the guy. Necessity for state management. So yeah, this, for instance, decouples state changes from renders. And I think this is basically what is it? Reflux? No. Okay, it's recoil. What recoil does as well. Even though it's not super obvious, it's more like yeah, event driven and data flow graph. But I think some of the main ideas is that you have more control over when you re-render. You know what? I'm not so sure. I think the efficient subscription part may be what I'm talking about here. But it might be that it's just more about, in fact, decoupling events from component renders. So that's like what I'm looking at, the ECS approach, right? Like decoupling state change events from component rendering and other systems in ECS terminology. And I think this is really what this buys us, is atoms that focus on state that changes and then subscribe a particular bit of yeah, using hooks. So it's hooks, right? Like recoils and hooks do this by subscribing subcomponents to state changes. But does it also do something smart about deduplication? It might not, you know what? or maybe debouncing or performance. I think it does, but performance, optimization, performance. Could not find what we're looking for. Okay, docs, uh, guides, synchronous data queries, snapshot, yes, code. Recoil, JS, performance, finish performance MD. Recoil for newcomers, it's a family from each. Each updatable kit to do making use of separate components. React memo to push state down to leaf nodes. Show what would be required. There was an initial list of to-dos. Next comparison. Hooks, MobX, recoil. Rendering reconciliation performance. Okay, sounds interesting. Recoil, state management. When state management library based on decentralized states work well, can reuse items, consuming level. It's mostly the wiring there that I think is different because in like compromise with simplicity and performance. Centralized states we're not sure to follow the decentralized logic. So that's decoupled, right? What I call decoupled. Mobile recoil. Okay. MobX is ultra performant. Only the component which consumes the properties of the get updated. Yeah, I suppose otherwise it's selectors. So it's mostly about routing here and avoiding re-renders and like we have targeted re-renders. Not so much about like this kind of stuff that Zustand does. Let's see, recoil. Zustand reversed. Okay. Zustand does with let's go to what I'm looking for. That shows like state sync back to React. I think it's okay if it's only synced from the hook to Zustand. Yeah, because it's just hooks remainder is composable. So things like recoil have ways to merge multiple atoms together. This becomes necessary because hooks naturally merge and compose. A solution to supporting the type of hook we already returns. See how we use this terms with any hook. Okay, so recoil's only quoted here once. This seems really interesting, but not so sure if this is what we want. It seems that these people are obviously aware of recoil. Okay, hold on. I couldn't see anything analogous in Zustand, which has the same organization, optimizations. Derive compute value from state. Okay. Can use getters. Okay, so that's sort of selection. You're saying that chain computed value in similar direction to recoil, how you handle selectors, be computed. Yeah, so it's kind of like, yeah, it's a state graph. It's really about, recoil is mostly about like this, yeah, state of derived, like a tree or graph of derived states, and then recalculating that like most efficiently, and then mapping that to state changes. But I don't think that that's what Zustand does. Although maybe meaning like a kind of declarative data dependency graph. Okay, let's also has a declarative data dependency graph to recalculate only what's needed. which to me kind of like spreadsheet and maybe even writing notebooks and things like that. And however, the stand, I think, is slightly different. Affected directly, for instance, using the stand, or subscribe in a way that doesn't re-render the component. And then basically it means using the on animation request or animation frame to do the render. So not try to do renders faster than the render rate, which is the smartest way, right? I think basically, yeah, a couple of stitches for renders. To instead give the render loop the control over when to poll state, basically, right? So that it feels like this is inching us each time a little bit closer to like more of an ECS perspective again, where you really see all of your state changes, like with ECS, like really optimize for data updates and traversal and derived states, and maybe some dependency aspect could be added in there, and then the very granular hooking of things into components. And then recoil is really about how states should be updated if it has lots of dependencies, and not so much about the decoupling of more of the rendering framework. Okay, so what does this mean for where we go? If we're able to decouple a little bit render loop from state management, at least conceptually, then maybe we get closer to how, for instance, we could hook things into React Fiber and be a little bit more modern in how we deal with the render loop. Okay, so let me go back to kind of a to-do here before signing off. Look again at decoupling state management from render loop and the render loop in Explorer. And then also I want to just think about whether hooks give the right decoupling I want, especially if I add if I kind of couple hooks to capabilities, then because inserting a hook into a component tree becomes a way to say you get this feature, but then the component tree still maintains its unity as a way to think of the UI, right? If you want to decouple things a bit more and say, well, there's this different UI component and they can be, um, they don't necessarily all have a relationship of containing each other, um, then we could probably still consider them as components and then hook them uh, more as a group. And um, and that would be a way to add some capabilities. But it's more about the relationship, I suppose, between hooks and this idea of um, input events and the right um, modularity, right? Because what we want is, so we could have component trees annotated with hooks. That's fine. But if we want to have more of a data transformation aspect, then does this work? And it could be that it does. It could be that like we have let's say we have a data hook, and then that becomes the live link to data changes coming in, and like what we were looking at with the GraphQL subscriptions. And then we therefore never really think of things happening inside components as events. We only think of like data modifications, and that's it. I think there's an asymmetry there between output in a component tree plus interface hooks in that component tree, and input from an external data source, which might trigger the same actions as interface hooks. So like yeah, like UI events, right? Can we straighten the asymmetry between those two things? Because there's not only the hooks, component tree annotated with hooks, there's also component tree annotated with these callbacks. So there's also the asymmetry between maybe somehow the hook and the callback. I think the hook, though, because it has both the data and potentially an updater, like it kind of have as a setter getter um, symmetry. Have this setter getter or getter setter symmetry. Um, which is sort of the data like that's the correct underlying data API. But then the event API is not really inputs and outputs like it would be in an FRP thing. But rather DOM event callbacks and like other event subscriptions. And that is just weird. So if we could we systematically um, move these into some, is it a global space? Is that what I want? That would also be strange, right? Um, maybe I don't want to move these to global space, but maybe I want to um, if I have a callback, do I want to do something like just passing it ink and be done with it? Like all of this wrap-free ink pure unit really is like we want to just send ink. So on key up, we want to pass on to on key up like some kind of ink that does all of this. And then that means, yeah, we wired um, our DSL, our monadic DSL to this. But if we wanted to reconstruct a kind of a data flow graph, like more FRP style from this, then then we need some kind of introspection, which is not nice. Or somehow um, what do? We pass ink to some wrapper that also somehow registers the graph dependency from that point in the component hierarchy so that it's somehow visible elsewhere. I'm not sure exactly why it's important, um, but it's kind of isomorphic, I suppose, in some ways to decoupling it. As the interpreter, have a UI component that relies on this ambient DSL, and then somehow hooking events from the top level. Um, if the UI data type was in some monad where I could use hooks, that would be another thing. Oopsie. And the way that I want to use hooks here is a little bit like the recoil way, right? I want to subscribe to a particular piece of state in a way that's very localized to where my data is. Um, so I'm not so sure that actually decoupling these event callback make a lot of sense. I think to have good local reasoning, actually, what I really want is to put uh, the data stuff close to where the visualization is. Um, and there is some regularity, I suppose, in doing like getter setter fetching from a hook and then displaying data and using the setter or updater in here. It's just that then the question becomes what goes on sort of underneath the hooks, I suppose, right? And how then that language of hooks compose. And I suppose each hook could have, I mean, we could have multiple hooks that draw data from different places and use this as a way to compose. But is that, I'm not even sure that we can keep, if UI was a monad, then would that even compose anymore? It might not. Like if we put an M in here, well, here, um, this might not it might not stay a comonad. It might depend on choice of M, and that might get ugly. Then, of course, the question of whether comonads are buying us anything, which gets us back to this idea of whether we can use comonadic shape for cursors. And so that's really, I really want to get into this fast. State management thing is good, but that's for, yeah, it's really about like continuing with events here. It's still based on this thought. But then the next one is That's not clear. I want to try cursors, and I want to try DB queries and then data flow. To be honest, data flow, I don't know even where to start. And even DB queries are that would be hard. Pretty sure I've already listed this somewhere. Yeah, I think this is my one of my examples of a. Basically, I've been using counters also, so I just need a better example. Um, um, Spaces 3, what the indent using spaces and 2. I was thinking something was strange there. Get a better example than counter and console. Should have state in it and cursors. Okay, that's it for me now. Thanks so much for watching. It was a little bit all over the place as usual. But next Tuesday, I'll be back in Berlin, and I think it's a little bit cooler there than here. So see you over there with more Purescript. Bye bye.